Dear students, welcome once again. In the last lecture, we have discussed about uh, definite as well as indefinite integrals in detail. And then we use some techniques and methods to find out the integrals, that is definite as well as indefinite integrals of the various functions. Now we will use the applications of the definite integrals in the various areas. So among many areas, one of the area in which we will use this technique or this method of definite integral is to find out the area of the different figures. In your earlier classes, you all know that we have a number of standard formulae, methods to find out the areas of the different geometric figures. Like triangle, we have a specific formula to find out the area of a triangle, square, rectangle, as well as circle. So all these standard figures are having their specific formulas to calculate their areas. However, if you have any such figure which doesn't fall in the category of any one of these standard figures, rather its one side or its region is closed by a plane, and if the region is bounded either partially or wholly by the curves, then what to do? So in such situations, we cannot calculate the area of such geometric figures which are enclosed by any curve. Enclosed by any curve means if any one of its side is closed by any curve. The type of the curve may be anything. So what to do if we are having such figures, or how we can find out the area of such figures? So naturally the techniques of the definite integral will come into the play. So in this session we will use the various techniques of the definite integrals to find out the area of such figures. Such figures means the figures which are framed or which are formed by using any specified curve. And further, we will extend the applications of the definite integrals to determine the consumers and producers surplus, right? So how we can find out the area of any geometric figure whose one side is enclosed or bounded by any one of the curve? Let us take this figure first, and then you will understand the concept how we can determine the area. So here we are having x-axis and y-axis, and we have taken a curve y is equals to fx, right? This is our curve. Take any 2 points on this curve, say this is P and this is Q, right? Now draw perpendiculars from these points P and Q on x-axis. Say this is a point, this is x-axis, this is a point, x is equals to A, and this is a point, x is equals to B, right? Write it here, this is x is equals to A and x is equals to B, right? Now we get a figure which is shaded by a color, right? So what is the figure? The figure is shaded by the color. We have to find out the area of this shaded figure, right? So shaded figure is what? If you this is PQ, take this as A and B. So the figure P, A, B and Q, this is a figure whose area we want to calculate. Right? Are you getting the point? We are interested to find out the area of the figure PABQ. You can start from any point, right? And the area of this figure, is enclosed by a curve, that is y is equals to fx. Means one of the side of this figure is a curve. This is the meaning of area under the curve. And area under the curve means this figure lies under the curve. That is why we call it as the area under the curve. Clear? So our objective is what? How we can determine the area of this figure ABQP. And this we can very easily achieve by using the techniques of the definite integral. So a very simple formula is required to calculate the area of this figure. So the area under the curve, what are the components? The area under the curve, y is equals to fx, the x-axis, and these two values, x is equals to a and x is equals to b, they are known as ordinates, is given by the integral of the function fx from a to b, or integral of the function y dx from a to b. You can use this formula or this formula to find out the area of the given geometric figure. Now, before proceeding the numerical questions, try to understand the formula. How does it work? See, the curve is formed by using three components. We must have a function y is equals to fx, that is known as a curve. Second thing, we must have an x-axis. And third thing, we must have ordinates, x is equals to a and x is equals to b. From geometry, at your 9th or 10th standard, if you are drawing any figure parallel to y-axis, it is known as ordinate. And if you are drawing any figure parallel to x-axis, it is known as abscissa, right? What I want to say this is your x-axis, this is your y-axis. Any line parallel to y-axis, this is called as ordinate, right? That is why x is equals to a and x is equals to b are known as ordinates. And if you are drawing any line parallel to x-axis, this is called as abscissa, right? So what are the components of this figure? Try to understand the components. We are having three components. One, a curve, y is equals to fx. See this. And second thing, x-axis. And the third thing is what? These two ordinates. So with the help of these three components, we can very easily determine the area of the given geometric figure using the formula, the integral of the function fx from a to b, or the integral of the function y dx from a to b. This means what? The area of the given curve, this, from the point this to this, can be calculated by integrating this function simply fx from point of initial a to a point of terminal b, right? Are you getting the approach how this formula developed? Simply integrate the given function fx or given curve fx from its point of initial, that is a, to a point of terminal, and simplify it. What else you will get as an integral that will represent the required area of the given figure, right? So before proceeding the questions or numerical questions based on finding out the area of different geometric figures using applications of the definite integral, let me explain one thing more. See, as I have discussed, we are having three components: the given curve, y is equals to fx, the x-axis, and the ordinates, x is equals to a and x is equals to b. So if these three terms are known, we can find out the area of any given figure. Now look at here, out of these three terms, y is equals to fx, this curve will be always given to you. It is given. Second term is what? x-axis, so this axis is also known. So these two terms are given. Always in the question are, known, right? What is left? The left quantity is only the ordinates. Now in questions we will encounter two kinds of questions. One, are you getting the point? These two terms are always given. The third term, ordinates, are either given in the question or they may not be given. If ordinates are given, then we have nothing to do. Use the formula directly. Integral of fx dx from a to b. In case 2, if ordinates are not given, then what to do? Ordinates means what? The values of x. Look at here. Ordinates are simply the values of x. And on this plane xy, what happens? On x-axis, the value of y should be equals to 0. So to find out the ordinates, if they are not given in any question, put y is equals to 0 in the given question and then simplify the given equation for the values of x. The values so obtained will be known as ordinates of the given question. Is it? So let me explain once more. We must have three components, a given curve y is equals to fx, x-axis. These two components are always given in the question. What about ordinates? Ordinates may given, ordinates may not given. If ordinates are given, then you have nothing to do. And in other case, if ordinates are not given, then put y is equals to 0 in the given curve or in the given function and solve it for x. The values of x so obtained, they will be treated as ordinates. And then you can use either the formula fx from a to b dx or y dx from a to b to find out the integral of the given function, right? Let us proceed. So before proceeding the numerical questions, look at few remarks. The integral y dx from a to b represents the area under the curve y is equals to fx, the x-axis, and the ordinates x is equals to a and x is equals to b. Look at these three figures here, figure 1, figure 2, and figure 3. If you revert the figure 1, in figure 1, the shaded figure lies above the x-axis. If you are reverting it just, reverting means if the same curve and the same figure lies the below axis, it looks like this. See, this is case 2. This is your curve, this is the point C and D derive perpendicular, and this is the region whose area you want to calculate. X is equals to A, X is equals to B, or the ordinate. Figure remains the same, only it has been reverted from above the x-axis to the below the x-axis. Then the area will become negative. Means whenever the area lies below the x-axis, the area should be taken as negative. That is why sometimes we use this symbol, integral of y dx, within the modulus. Modulus, I have told you, modulus is a function which converts every negative value to the positive one. So these are the two cases. The case third is what? Here in figure 1, our axis is x. If you shift this axis on the y-axis, if the situation is like this, see, this is case 3. This is x-axis, this is your y-axis, this is a curve. These are the 2 points, derive perpendicular from C on y-axis and derive perpendicular from D on y-axis. Now here x is equals to A and x is equals to B were considered as the ordinates. Now here y is equals to A and y is equals to B will be considered as abscissa. So what will happen? What changes? Similarly, the area bounded by the curve x is equals to Fy. Now what happens? First we have taken y is equals to fx. X and y are interchanged. If y is equals to fx, then x-axis is one component. And if x is equals to fy, then y-axis will be taken as one component of the figure whose area we will calculate. So the area bounded by the curve yx is equals to fy the y-axis and the abscissa y is equals to a and y is equals to b, as shown in the figure 3, this one is given by integral of x dy. Naturally, in case 1 we were having y dx, so x and y are interchanged, therefore in place of y we will have x. So the formula is integral of x dy from a to b. Similarly, if you revert the third figure to the fourth one, this one, the things are as usual, but it has been shifted from right hand side of the y-axis to the left hand side of the y-axis. Then what will happen? Then the area is calculated by, we will use the modulus, right? So these are the 4 possibilities. Out of these 4 possibilities, 2 possibilities are very important. We should use the single formula to calculate the area a to b fx dx, right? Or a to b y dx. This is the main formula to calculate the area of any curve y is equals to fx, x axis, and the ordinates x is equals to a and x is equals to b. Okay. Now let us proceed for the questions. See example 1. Find the area bounded by the function y is equals to 2x plus 3, the x axis and the ordinates x is equals to 1 and x is equals to 3. Now don't get confused. Try to understand the approach. What I have told you just now, you must have given 3 components. The curve should be given, x axis is already known, and the ordinates is the third component. So see here what is given to you. You have given the function y is equals to fx, the curve. This is your curve. And then x axis is already known, and fortunately ordinates are also given, right? Y is equals to fx. Fx is what? Here fx is 2x plus 3, right? This is your curve. X axis is also there, right? And the third thing is what? The ordinates x is equals to 1 and x is equals to 3. And you know what is the formula? The formula is a to b y dx or fx dx, whatever you use. And what is the value of a to b? A is from 1 to 3. Fx is 2x plus 3 dx. Simply integrate the function 2x plus 3 dx and substitute these limits. Simplify it. What else you will get? It will be considered as an area of the given figure. So naturally this is what? 2x square by 2 plus 3x from 1 to 3, right? 2 and 2 will be cancels out. What is left? X square plus 3x from 1 to 3, right? We are getting same thing. Now substitute the limits. X square plus 3x means 3 square means 9 plus 3 into 3, 9. In first bracket, minus 1 square means 1 plus 3 plus 1 is 3. So 9 plus 9, 18 minus 4. What is left? That is 14. 14 is only a number. You must mention the unit. 14 square units. Now it will be considered as an area. Don't write only 14. Only 14 is the number, right? Likewise, take another case. Find the area bounded by the curve y is equals to x square. Look at this. This is your curve. The x-axis, the curve is given, the x-axis is given, and the ordinates are also given, right? So all the 3 terms are given, right? And you know the formula to calculate its area. But before calculating the area, you know this is the figure of the curve y is equals to x square. You can try to draw this figure yourself at your home. How you will draw? See, if x is 0, what is the value of y? Y is 0. It means this curve passes through the origin. So see, it is passing through this is the origin, right? If x is 1, see what happens. Then y is also 1, right? And if x is minus 1, even then y is 1. So for 2 values of x, we are getting a single value of y. So naturally, if you take here like this is x, this is y, this is x-axis, this is y-axis, this passes through the origin. X is 1, y is 1, this point, x is minus 1, y is 1, this point. X is 2, what is y? X is 2, y is 4. And x is minus 2, even then y is 4. So you will get here this and this. So join all these points, you will get a curve like this, right? So that is how it looks like this. This is a curve of the function y is equals to x square. This is called a parabola, a standard figure in geometry. Now determine its area from x is equals to 1 to x is equals to 4. See, this is x-axis, this is the point A, x is equals to 1, this is the point B, x is equals to 4. Draw a perpendicular from here and here. So the shaded portion is the required area which we want to determine. And the area can be calculated by using the simple formula. The area is given by integral from naturally 1 to 4 y dx. Y is equals to given as x square. And you know the integral of x square is x cubed by 3. Substitute the limit in this integral. 4 cube is 64 upon 3 minus 1 upon 3. So 63 upon 3, and it comes out to be 21 square units as the required area of the given function, right? So see, what we observe in these two examples, if you look at carefully, in these two examples, all the three components which are needed to find out the area of any figure are already given. The curve is given, x-axis is already there, and the ordinates are also given. This is case 1. And I have told you we can have two kinds of questions regarding the area under the curve. Case 1 is this, all the three components are given, and case 2, what the examiner can do, he can at least remove condition 1. Ordinates may not given. Curve must be given, x-axis is already known. So let us take the example of case 2. Say, fortunately here is also, this is another example. Find the area enclosed by the line y is equals to x, x-axis, and ordinates x is equals to minus 2 and x is equals to 4. Oh, here in the last two exercises, our questions, the ordinates were positive. X is equals to a and x is equals to b. This a and b both were positive. But here, one ordinate is negative, right? So find the area enclosed by the line y is equals to x, x-axis, and the ordinates x is equals to minus 2 and x is equals to 4. Look at this figure. So y is equals to x. You know, this is the x-axis, this is y-axis. If you wish to draw the graph of y is equals to x, you all know this. If x is 0, then y is 0. It means it passes through origin. X is 1, then y is 1. X is 2, then y is 2, right? If x is minus 1, y is minus 1. X is minus 2, y is minus 2. This means what? The values of x and y both are same. If you mark all these points, this is 0, 0, this is 1, 1, this is 2, 2, this is 3, 3, this is minus 1, minus 1, this is minus 2, minus 2, this is minus 3, minus 3, and if you connect all these, you will get a line like this, right? This is the graph of the line y is equals to x as shown in the figure, this line. See. What are the ordinates? This is our x-axis is already given. Ordinates are given from minus 2 and 4. So look at here, this is 0, right? 2 will be, minus 2 will be somewhere here, and 4 is somewhere, say here. Extend this line further. So draw a perpendicular from here and draw a perpendicular from here. This is the shaded region and this is the shaded region. Take this point as C, take this point as A, and this is your origin, right? So you want to determine the shaded portion. See, the shaded portion is divided in two parts. Part 1, this part lies above the x-axis, but this part lies below the x-axis. And we have just discussed, whenever the area lies below x-axis, the area will be negative, right? We will use the negative sign. So whole area is what? The required area is the area of OAB. This is OAB, yani this area, this one, right? And OCD, this area, right? Okay. Now, how you can find out the area of OAB? The area of OAB, integrate the function y is equals to x from 0 to 4. 0 to 4 y dx is the area of this portion. Integrate the function from minus 2 to 0. Minus 2 to 0, but with negative sign. So this will be minus y dx from minus 2 to 0, because this portion lies below x-axis. So we will use the negative sign to calculate its area, right? Now you can integrate it. The integral of y, what is the value of y? Y is x, 0 to 4 x dx, right? Plus minus 2 to 0 minus x dx. Now the integral of x is what? X square by 2 from 0 to 4, plus the integral of minus x is minus x square by 2 minus 2 to 0. Now substitute these limits and you will get as 8 plus 2, that is 10 square units. See, 0 to 4 into 4, that is 16 upon 2, plus, what about this? See here, this is, first is 0, so minus sign is here, this is 0, minus, put minus 2, so minus 2 square is 4 by 2, what is left? This is 8 plus minus minus plus, this is 2, that is 10 square units is the required area of the given function, right? So just try to understand, whenever the portion of the figure whose area you want to calculate lies below x-axis, we will use the area with negative sign, minus y dx, right, as we have used here. Now take up the next case. This is the case 2. See, find the area intercepted between the curve x square minus 2x minus 3 and x-axis. So look at this example. This is the example of case 2. Case 2 means in which the curve is given, the x-axis is already there, but look at here carefully, the ordinates of this question is not given. But without ordinates, you cannot calculate the area. You need three components, the curve, x-axis and the ordinates. So what is your objective? First, determine the ordinates for the given curve. So your curve is what? Your curve is y is equals to x square minus 2x minus 3. This is your given curve, right? What you want to determine? You want to determine the ordinates. Ordinate means ordinates are simply the values of x. And you know, on x-axis, y is equals to 0. So putting y is equals to 0 in this equation, putting y is 0 in above equation, what you will get? X square minus 2x minus 3 is equals to 0. This is a quadratic equation, right? Find out its root or factors. So naturally it will have two factors, and you all know how to find out the factors of a quadratic equation. It means minus 3 is the number. So find out the two factors of minus 3 whose sum is coming out to be minus 2. So 3 into minus 1. Look at this. The product of these two is minus 3, and 3 minus 1 you will get minus 2, right? So this can be written as x square minus 3x this, and minus x minus 3 this is equals to, sorry, plus x square minus 3x plus x, you can write it as minus 2x, minus 3 is equals to 0. Now take x common, x minus 3 is here, take plus 1 common, what is left? X minus 3 is here, this is equals to 0. So we get x plus 1 and x minus 3 is equals to 0. So this implies x is minus 1 and x is 3. Right? So minus 1 and 3 are the required ordinates, a and b, in the formula. A and b are the limits of the integration. So minus 1 and 3, they are considered as the ordinates, and naturally if ordinates are there, then you can use the formula. The required area is given as, this is a is equals to minus 1 to 3. What is the function? X square minus 2x minus 3 dx. Now simply integrate it. So a will be equals to, the integral of this is x cube by 3 minus 2x square by 2 minus 3x from minus 1 to 3. This 2 and 2 will be cancels out. What is left? This is x cube by 3 minus x square and minus 3x from minus 1 to 3. Now substitute the limit and then simplify it. So what you will get, a will be equals to 3 into 3 into 3, that is 27 by 3, minus 3 into 3, that is 9, minus 3 into 3 is 9. This is bracket 1, minus, used for minus 1. Minus 1 raised to the power 3 will be minus 1 upon 3, minus 1 square is plus 1, minus 1, and minus 3 into minus 1, that is plus 3, right? So the value of this and this will come out to be as minus 32 upon 2, and area, you know, can never be negative. Therefore we will not use the negative sign, and we will write the area as simply 32 by 2 square units, right? So this is how you can calculate the area of different figures whose one side is closed by any curve using the techniques of definite integral. So students, we should stop it here and continue the next applications in the next lecture.